Hi, and welcome to this video about solidThinking Compose. In this video we will take a look at how to input a sequence of numbers, vectors and matrices into the console. Let's get started. So I have opened a new Compose window and I have a console down here. And I want to first input a sequence of numbers. For example, I want to get the values between 2 and 12. So I just input 2 colon 12. And this gives me a matrix, it's indicated here, with 1 row and 11 columns. And though the values are 2, 3, 4, 5, up to 12. So how does Compose know about the step size? Well, it just assumes that the step size is 1, unless differently specified. So I could specify the step size if I just input 2 colon 3 colon 12. Now I get the third element in this area, so 2, 5, 8, 11. You can see that when I change the 12 to a 13, for example, the output stays the same because 13 isn't enough to go from 11 plus 3. So I had to specify at least 14 for that, and then the 14 would be included. Another way to specify a sequence of numbers is with the method called Linspace. Linspace lets you define a lower and upper boundary, and you can specify the number of values which is equally spaced between there. So, for example, I could say Linspace 1, 2. I have to say that I have to put a comma between those values, 1, 2, and I want 11 values between 1 and 2, for example, and then you can see that I have those values. So that's a pretty cool method. Now about the vectors and matrices. Vectors and matrices can be inputted as with brackets. So for example, I have a vector called A equals brackets 1, 2, 3. So I have this one row and 3 columns, which you can also see here. It's a matrix 1 by 3, and this would be just a vector like this. If you want to have a column vector, you could transpose, for example. So for example, B equals A transposed. So that's how you could get to a column vector, or you can define it as A equals, again, the brackets, and you have to just put a semicolon after each value, 1, semicolon, 2, semicolon, 3, and now you get a column vector, because semicolon indicates that a new line, new row is generated. Alright, well, now to the matrices. A matrix is just the same as a vector from the input syntax. For example, A equals brackets 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9, and you have your matrix 3 by 3 with those values. And you also can transpose your matrix with that. Now, in your calculation, often there's a need for certain standard matrices, and those matrices can be generated rather easily with certain functions, and I want to talk about that now. So for example, if you want to just have a matrix with zeros in it, you can just say A equals zeros and specify a number in here. So if I specify one number, it just assumes that the matrix is symmetrically, so it has 3 columns, 3 rows, like this. If I want to specify a asymmetric matrix which has just zeros in it, I can do that as well. 2, 3, for example, equals 2 rows and 3 columns, as indicated here. Now, zeros is one way. The other way would be a matrix with just ones. And I think you guessed it already. Ones, 2, 3. Same syntax as the zeros, but the output is different here. Just has ones. I have also the possibility to define a matrix which has just ones on a diagonal. For example, I could just say I and a 4 in here. So I have a 4x4 matrix which has ones on a diagonal. And yeah. Let's just jump back to the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. If you want to have the diagonal elements of a matrix, you can simply do that by calling the diag function, and you just have to define the matrix in here, and you get a column vector back which has the diagonal elements of the matrix you specified in a function call. You can also repeat a matrix into bigger matrices. So for example, just define a small matrix, R equals 1, 2, 3, 4. And if you want to repeat this matrix 4 times in rows and 3 times in columns, you can do that just by calling the repmat function, specifying first the matrix you want to input, then the numbers you want to copy that into the bigger matrix column-wise, so for example 4, and then row-wise. Sorry, other way around. First is row-wise and the second one is column-wise. So if you put that in, you have your matrix, which has 4 times the matrix in your rows and 3 times the matrix in columns. Often there is also the need for having random values in your matrix, and that's also possible. You can just say A equals rand, and again the syntax is the same. You can just say 3, then it is a symmetric matrix with 3 by 3, or you could say 3 times 4, then it would be asymmetric. So that's another way. And the values are also always between 0 and 1 and are randomly generated. Well, that's about it for matrix input and vectors input. I hope you enjoyed the video. If you want to ask a question or something like that, leave a comment, leave a thumbs up or subscribe to this channel, and I hope to see you back soon. Thanks for watching.